I'm Dan Hulse at Excel Fluid Group. I'm one of the mechanical designers here, and I'm going to walk you through an assembly of our NV2, which is one of Excel Fluid Group's flagship products. Handles fiberglass, HDPE, and ductile iron piping up to 4 inches. These are the sub-assemblies that we have pre-selected. These are all pre-engineered to fit based on the depth and type of specifications that are needed. And I'm going to walk you through all these things. And our assembly process. Try not to geek out too much. I'm opening up a new top-level assembly. And I'm going to first drop in the basin and align that up to my predefined planes, front, top, and center. And this is a fiberglass basin from Top Industries. And I've already determined the diameter and depth on it. And I'm just going to line this up. Front, top, and right planes. Planes are reference geometry in SolidWorks. I've been using SolidWorks since 1997, which it's been a while. And I'm offsetting the top here because we're using, in this instance, a polymer concrete, which is 6 inches thick. And here you can see the dimensions. I can either predefine these or I can change these on the fly if we need to adjust. I'm going to insert the second sub-assembly at this point. I'm just picking from my list that's already open. We have a catalog of several hundred sub-assemblies. This is the castanite top. And that is actually a conceal that goes onto the on the underside of the top and the top of the basin to seal that. And I'm going to align it here. You can tell the hatch is already cast in place and the penetrations are set up for our NV2. We also have 2 other sizes of no vault unit. NV is no vault. And I've offset this just slightly because, here I'm bringing in the NV2 unit, you can see here. Does have a slight offset, so it's not completely centered front to back, just so the hatches fit. And I'm lining up the penetration on the no vault to the penetration on the polymer concrete. Still setting it in some, locking it down into place. That's our electrical side. This is our piping side, which you can't see the piping yet because that's not there. But we do have the lighting is already pre-installed in this building, as well as the pump lifting hoist. And this is a PVC 4-inch pipe header with ductile iron check valve and plug valve. It's also got an air release on it and a bypass, and I'm just aligning it to the predetermined places in the no vault and locking it in so it doesn't keep spinning around like that, because that would be bad. Again, we've pre-engineered these components to all work together, and we can do anything, any size piping up to 4-inch PVC, HDPE, or ductile in this unit. This is just a wireframe, kind of an unshaded view to give you a little bit better detail. Sometimes black and white is a little more clear. A little close up. You can see our heater in there. It's pre-plumbed. Going back to shaded view. And we're going to add the next component. This is going to take us through about 90% of this assembly. There's a couple of items that would still be added that I didn't show in here just for the sake of time and interest. I did not include the float brackets and the float stilling tube. This is the BAF assembly, base elbow flange. Also includes the guide pipe and the upper guide rail bracket. I'm sectioning the basin here so I can see what's going on the inside. Just one way of doing it. And I'm going to align, once I figure out, oh, there's the section. A little eye candy, you can section that however you want, left to right, top to bottom. SOLIDWORKS is a cool program. Been using it for a long time and I still think it's cool. Aligning the bottom of the BAF to the internal pad in the vault, wet well vault. And I'm using flexible assemblies. So we have this assembly will fit, they're like 5-foot increments. And if everything works well, it's going to auto trim that pipe as I rebuild. I love it when that happens. And I'm going to attempt to line up the bracket, and obviously I made a mistake here. So SOLIDWORKS tries to help you not be stupid and make silly mistakes, but every once in a while you grab the wrong edge and it gives you an error. I mean, you can force things to be stupid if you want, but ideally you want to make something, design something that can be, that's designed for manufacture and is accurate. And that's the whole point, right? So I'm aligning the bracket to the skirt or the inside of the hatch, what I affectionately call the center of the universe, because if it's lined up to the hatch, you know that the pumps are going to be able to be removed appropriately, and there's not going to be any interference. And I'm going to continue to line up the assembly in just a moment. Just gives you so I'm doing the offset right now. Our 4-inch NV2 spacing is 26¼ inches. Half of that is 13⅛. That's from the center of the assembly. And you can see that's fully defined. Next, we're dropping in the pump here. This is a Barnes pump, 4-inch. We're lining that up to the BAF. And we either download components if they're available, or we simply model them based off of 2D information, the best information that's available from the manufacturer. Obviously, we do not make pumps. We integrate these units to work seamlessly together. And all this is important because we want to make sure that in the end we're checking for clearance. And next we're putting in the discharge piping. It's gonna go from the BAF just line that up here. You can see there's fasteners in here already defined. We know which fasteners are going to be in there. So there's also a U-bracket, a U-bolt bracket that is used for pipe support. And about to do something else silly here, and it's giving me an error. All right, so there's better ways to skin a cat besides feeding it a stick of butter. And I'm just aligning the piping. I already know what the offset is. It's set up to align the pipe, which is again pre-engineered. The offset's already been determined. So line that up. And that is fully defined now. Okay, so now I'm going to do a linear pattern, which is to create the second pump, BAF assembly, and discharge piping. And I'm just going to offset that based on my pump spacing. Just creates a second copy. Speeds things up a little bit. Next we have our discharge pipe. This was based off of a very deep force main discharge. So this is a custom one-off slightly. We've got standard part number assemblies for most of our discharge pipings, but this is a custom for the job that we're doing here. So I'm aligning that to the center discharge leg of the pipe header, and I'm setting the depth here. Discharge is usually center line of the pipe to the top of station elevation. And should be a drum roll here. Here we are. Gonna show my basin again and the finished product. Thank you for your time.